Well, this is a special case. It's the difference of two perfect squares, and so you've got to look for that because it's too tricky to try and have to do otherwise. But if you notice that you have two terms that you're factoring, both of which are perfect squares, and you have a minus in the middle, you're going to be able to factor these into conjugates. And conjugates are basically the square root of this, the square root of that, with a plus or a minus in the middle. Okay? The square root of 9x squared is 3x. So we're going to put a 3x in both first spots. The square root of 1 is 1, so we're going to put a 1 here and a 1 there. Now, there was a middle term when we did this one up here, but there's no middle term here, and that's because one of these is a plus, one of these is a minus. So what happens is that that outer and that inner term, the negative 3x and the positive 3x cancel out, and that's why there's nothing in the middle. Okay? And I'd like you to get to the point where you can kind of go without a diamond problem. The thought process is the same, but instead of drawing this and doing extra work to say 2 and 3, you can instead of saying, well, two numbers that multiply together to get 2 and add together to get 3, look at this. Two numbers that multiply together to get 2 and add together to get 3 are still 2 and 1. X plus 2 and x plus 1. Now, it's okay to do this, but the thought process is the same as you're looking at the equation without having to do the diamond. So consider that and think of that as you move forward. So here, same thing. Multiply to get negative 8, add to get negative 2. That is a negative 4 and a positive 2. They multiply to get you negative 8, and 2 minus 4 is negative 2. X minus 4, x plus 2.